easy go.
Hello everyone, my name is Ali. Today I will represent my microprocessors Lab4 project. This project is about comparing two protocols, SPI and I2C. To compare the two protocols, I used BME280 temperature sensor and STM32 microcontroller. I programmed STM2 microcontroller with bare metal programming, and I showed results on the computer with UART. Let's look at the results. I used two sensors for two different communication protocol. This one is using SPI communication. No, this one is using SPI communication, and this one is using I2C communication. Now you can see here the live data. If I press this sensor, because of my body heat, you can see that data is rising. Now I left my finger, data is dropping very fast. Now if I press this other button, other sensor, and you can see I2C values rising. And for your information, I2C value dropping very faster than SPI temperature. I think because of the protocols. The core of the project is the bare metal implementation. I didn't use any high libraries. I configured everything using direct bytewise operations. For example, here in the installation functions, I am manually routing the hardware pins using the GPIOA, modar and alternate function registers. I also set the SPI baud rate prescaler to 64 directly in the CR1 register for breadboard stability. In my SPI transfer function, to prevent the data corruption over the jumper wires, I strictly poll the hardware flags. You can see here that I wait for the TXC and RX and E status flags in the SPI status register for every single byte transferred. For the I2C driver, retrieving data from the BME280 requires a repeated start condition. I manually implemented this right here. After sending the register address, instead of sending a stop condition, I set the start bit in the CR1 register again before switching the read mode and handling ACK neck sequences. Finally, the standard printf function doesn't support floating point numbers by default on this MCU to save memory. Instead of enabling heavy float libraries, I wrote a fixed point integer math workaround. As you can see here in the main loop, I use a division and modulo 100 operators to format and accurately print decimal values to the terminal. Now with this project, we understand that SPI and I2C protocols, and we know a lot more about them. Thank you for listening to me, and bye bye.